Hello everyone, thanks so much for joining us for this webinar. My name's Anthony Janot. I'm the new social and content executive at Erlang Solutions. So please at any point jump on social and say hello. For the start of this webinar, if you can't see Bruce Tate's screen at the moment, please do jump on the chat and let us know. We are so excited to be joined by our special guest presenter, Bruce Tate, today. For those of you who don't know, Bruce is an extremely active member of the Elixir community. He has a long list of credentials as an author, as a presenter, and he will be the keynote speaker at our Code Elixir event in London this July. He's a teacher who set up an organization called Groxio Learning, and he's also the event organizer of Gig City Elixir in Tennessee and Lone Star Elixir in Austin, Texas. Bruce's most recent book is titled Designing Elixir Systems with OTP, Write Highly Scalable Self-Healing Software with Layers. And that will also be the topic of his talk today and webinar. At the end of the webinar, we're going to have details on exclusive offers for that book that Bruce has kindly provided for attendees of this webinar. So please stay tuned for that. As always, we'd love to know what you think, so please do tweet us at Erlang Solutions during the webinar, and we'll have a Q&A at the end of the session, so tweet your questions over to us or pop them in the question box of this platform. With that, let's hand over to Bruce and enjoy the webinar.
Greetings, everybody. This is kind of like watching a mission control launch. You know, there's this attendees count, and it keeps going up and up, and it's pretty exciting. I want to say thank you to Erlang Solutions and everyone there for a couple of things. First, Joe Armstrong's passing hit me pretty hard, and the way that that Erlang Solutions kind of stepped up and became the place where we could go and share those stories was powerful and moving for me. So thank you very much for that. Also, I would like to thank Erlang Solutions for the work on Code Elixir in London. I'm very excited to be there to keynote that event and to actually join the community there. It's coding and writing and presenting have all become international things, and it's a very gratifying thing. So thanks to all that are going to be involved with that. So before I really get started, I want to point out a couple of things that are happening that you might be interested in. So I have a couple of things going on. So on your left-hand side, you can see the Groxio Learning. That's a new company that I've started. We've actually done a soft launch. We haven't really done too much with it yet. If you want to know what's happening with it, you can go ahead and subscribe to our newsletter there. I also want to point out that we have a promotion code for designing Elixir systems with OTP. This has been a very exciting project. First, because I had the opportunity to work with a close personal friend, James Gray, and just writing with him and tapping his knowledge and deciding how to best unify his design experience with my teaching abilities has been just a load of fun. So there's a promotion code, Webcast Tate 2019. You can see it there on your screen. If you don't worry about grabbing that now, it'll be in the thank you email after this webcast. It's good for 20% off, so it's a pretty good coupon. And this is already has the beta discount, which is a pretty heavy discount in its own right. So I'd also like to point out that there's a couple of conferences that you should be aware of. One is Gig City Elixir, and that's in Chattanooga, Tennessee. And I noticed, Anthony, that you didn't try to pronounce that. It was probably a pretty good call. And the second one is in Austin, Texas. So Jim Freeze has run that conference for, seems like forever now. I think it's 6 or 7 years. And that conference eventually became the national conference. But as he moved from Austin, he wanted somebody who could give it some more time and attention. And so Maggie and I are going to be taking that on. So if you want to reach us, you can find me at Red Rapids. You can find Groxio and all of our communications at that Twitter handle is wrong. It should be Groxio Learning. And you can reach our various conferences at Gig City Elixir and Lone Star Elixir. We're pretty active on Twitter. That's tends to be where most of our customers are. So we're active there, and that's the best way to reach us. So with those announcements, let's go ahead and get started. What I'd like to do is do some live coding today. And these are based on the principles in the book in designing Elixir systems with OTP. And before I really get started, I think I'll point out a couple of things. If you haven't gotten the beta program, definitely jump in as the chapters are getting written. It's very exciting to see people talking about the chapters and actually providing feedback on the chapters as they're being written. You have a voice in what this book looks like. And as the editor responsible for Elixir content at the Prague, that's basically our publisher. We think that this is a very important title. It talks about how to build our applications, not just OTP applications, but especially OTP applications. It talks about how to build those things in layers. So before I get too far along, I'd like to talk about how to remember the layers so you can understand what you're seeing today. So we have a very cheesy but very memorable mental mnemonic, and that sentence, and I'm going to give you a pause so you can repeat it with me. And even though your microphones are muted, I can hear you because I have that mental power. So the first half is the core layers. It's do fun things, and that stands for data, functions, and tests. And the second half is the boundary layers, and that's with big, loud wildebeests. That's big, loud wildebeests. So I'll let you repeat those after me. Do fun things with big, loud wildebeests. Your turn. Yeah, Fred, I could hear you. You didn't say anything. So, but anyway, that's the layers. So they're do fun things, data, functions, tests with big, loud wildebeest. That's boundaries, life cycles, and workers. And we're going to get to at least 4 of those. We'll talk about a 5th one. I'm not sure how long it'll take. You might have noticed that rather than putting this webcast under my own company's name, I used Erlang Solutions, and the reason for that is that this is a live coding presentation. So things often go very wrong, and I don't want my name fully associated with that. So thanks guys for taking the risk with me. We're not going to build a massive application, self-healing application. If I could do that in 45 minutes, I wouldn't be doing webinars. So what I thought we could do instead is an application called Roam, which is just kind of moving the representation of a little rover around. So this application is going to be able to do 3 things. One is to go forward, one is to turn right, and one is to turn left. And what we'll do is build this application in layers and then kind of talk about where the boundary crosses from what's a library and what's OTP. So let's go ahead and get started with that. I'm going to say mix new. I'm going to ask for a supervisor. And that actually, the supervisor, you might have noticed that one of our layers is not a supervisor, and it's actually there. It's the with big loud. So that loud we say stands for life cycle, and that's where the supervisor fits. And I'm going to call this application roam, just because it goes from place to place. I'm going to change into that directory, and let's write some code. Well, not like that. So let's write some code like this. Okay, so I'm going to bump my font a little bit. I can bump it on the right-hand side with the letter this editor, but not the left. So bear with me if you can't see what's happening on the left too well. I think that most people should be okay. So I'm going to start where we start with most of our Elixir applications, and that's in the code. And you can see that since we specified the --sup flag for supervisor, I got an application file. And this is, so in the code structure, inside the Roam directory, I'm going to start with two pieces. And those are, so our mental mnemonic was do fun things, and those are the core layers, with a big loud wildebeest, and those are the boundary layers. So I actually like to start my applications. You don't have to do this, but I like to separate the core code. And I also like to have a boundary layer. So I like to do this because when we introduce complexity to an application, complexity isn't a bad thing. Unlimited complexity is a bad thing. So what we'd like to do is introduce complexity in layers. And so the main concept of this talk is that it's a valuable thing, even though it takes a little bit more effort to expose complexity piece by piece. Now, I want to point out that you don't have to use every single one of these 6 layers in every single application. In fact, in our book, there are 3 different pieces that we build, 3 different major pieces, and one of the pieces called persistence. We basically add that as a dependency. And since that is they're all boundary concerns, all of our persistence actually is going to live in boundary. So we don't introduce a boundary folder at all. So it's important to basically use this tool as a crutch to help you remember, help you think and visualize what's happening, but not as something that we have to be a slave to. So let's go ahead and start the work on our code with the data layer. And so our data, the main piece, is going to be called a Rover. So let's introduce that piece now. This is an Elixir file, AX extension. And so I can do this 2 ways. One, I can make the boundary and core pieces kind of silent, but just for the sake, or I can make them track our directory structure exactly. And I'm going to follow conventions and do it that way. But if you want a flatter, name spacing, and you're okay with breaking conventions a little bit, sometimes rather than have all these pieces in the namespace, I'll flatten it out a little bit by omitting that core and boundary. I'm not going to do that here. So I'm going to say that this is roam.core.rover. And so in this, the very first thing that we want to do is start with the right data. And I wanted to talk briefly about what the right data in a functional application means. So in functional programming, particularly in Elixir, one of the things that we like to do is think in terms of reducers. Now, a reducer is a function that works inside enum reduce. So let's actually jump into IEX for a second. So a reducer, I'm going to move this up. I hope everybody can see that okay. I'm going to start with a list, and I'm going to pipe that through enum.reduce. And this is going to take a function, and this function is what I mean by reducer. And when I use the term reducer, I'm talking about something that has an accumulator and an item that we work on. And I'm not really talking about the exact shape of the function, and I'll tell you why in a second. So this function is going to take an item, and it is going to basically do something with them, right? And so that basically gives me 1 + 2 + 3, which is 6. But the concept is that a lot of what we do in Elixir uses these reducers. So one of the things that I think about when I think in terms of Elixir is that I think in terms of a token, not like a web token or anything like that. This kind of token is something that moves around a game board. So think back to when you were a kid. Maybe you played a game called Monopoly where there were squares, and maybe one of the squares was called Go. And maybe you rolled a 7 and you would start to move your token around the board. And as you moved the token around the board, the state of the game changes, right? And that board and the token is just a way for us to remember the state of the game at a time, and so that we can play it. And that's the way I want to imagine this data structure. And actually what's going to happen with this rover as it moves around is I'm going to have at least 2 things. So I'm going to use a structure here, or a struct here. And the 2 pieces that I know I'm going to have at least a position. And I'm going to start our rover at the origin. I'm going to have a two tuple. And then I'm also going to have an orientation. And rather than make this super complex, I'm just going to have 4 particular directions, and I'm going to start it facing north. And then I'm going to also track moves. So in a functional program, often the structure of our data just accumulates a piece, at least one of the pieces of data. So if you think in terms of a bank account in an object-oriented system, maybe the most important piece of that system is the balance. If you think of a data structure in a more functional system, maybe the most important piece of that data is the transactions, right? So actually doing transactions on a bank account basically means that you're going to start with an initial balance and then have transactions that are applied to it. And then we basically reduce over those, and maybe we take checkpoint balances along the way or something like that. So we don't have to reduce over 20 years of accounts, but that basically gives us a lot of things. The main thing is that as we are modifying the data, the modifications, since they're all additive, we don't have to worry as much about the mutability. So let's go ahead and put this thing through our paces. So I'm going to say IEX start mix, and I'm going to go ahead and alias. So we have the application that has a core layer, and the only thing in the core is a rover. So basically, I'm going to work with the rover in this way. And so to get a new rover, I'm going to basically call the __ struct method, and that's going to pick up the defaults in my application, right? So this works great, and I think that if we wanted to test this as we go, normally if I had a longer class, I would write a test to basically pick off my defaults and make sure they're what I expected them to be. But I think I'm ready to move into functions because we're a little short on time. One of the things that I like to use functions for is to name concepts. So when I look at this does not look pleasing to me. Basically, it doesn't name well the concept that we are building a new rover. And I'd like to do that. And the reason is that I like to design my APIs at a single level of abstraction. And that means that that maybe my API is going to look something like this: rover.new, and then pipe a move forward and another move forward and another move to turn. So new, move, move, move sounds like a single layer of abstraction. But if I have to think in terms of rover.__struct__, that's a little bit more awkward. And our brains just don't process it as cleanly and as quickly. And I know I'm going to get some pushback with this on the questions, but I'm going to write a one-line sentence or a one-line function. And that's called new. And I'm going to pass it in the fields. And I'm going to default those to an empty list. I'm going to use the one-line function. I believe that that sometimes one-line functions are valuable. Basically, I'm trying to condense things top to bottom. And I know that I'm representing a single concept here, so it feels like a good trade. And I'm going to go ahead and make that trade-off. So I'm going to say the module, which is essentially this thing, and I'm going to call that. Oh, I actually don't need that too. I can just call struct here, right? Struct, and then I'm going to take the fields. All right, so now, so I can recompile this thing, and I can say rover.new. And this pleases me. I just think that this new names the concept exactly like we want it to. So let's go ahead and think of our main API. I think that what we'd like to do is we would like to take a string of instructions that looks like this. Maybe forward, 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 right, forward, right. So this would move the drone forward, change the orientation, move it forward again, and change the orientation, right? So the most important piece of that is going to be a rover.move. And I'm going to take a rover like this one. And then I'm going to take an instruction, and the instruction is going to be a single character. And I might make it a character like this, but I know that if I think in terms of code points, Elixir is going to be a little bit more friendly to me. So that's what I'm going to do. And what I mean by code point, so many beginning Elixir developers don't understand exactly what's happening with strings. But a string is basically a form of this thing called a binary, right? So if I have an A, so if I have a C, C would be like 99, and then an A, which is 97, and then a 98. So that's a binary, but that thing is also a string. So this basically is a bit stream where we are actually putting the bits into this structure, one after another. And since these are even units, this thing is called a binary. So a binary is a bit stream with an even number of bits in it. So there's another version of this thing that I can use, and that is a 99 is 99. This is a string, 97, 98. And so this thing is actually going to be a single quote. It is a, so essentially single units of code points. And so the code point for A is a 97. So we're actually going to, our API is going to use this version because it's easier, it's more flexible for us to build than this one, and you'll see why as we go. So, and then if we needed to, we could have helpers to convert the list of characters to the binary composing characters in that way. So let's say that that we want to move the rover, and then I'm going to take a rover, and I'm going to take an instruction like a forward. Okay, so let's go ahead and do the very first piece of this. And that's going to take a rover, and that is and it's also going to take a move. And I'm just going to have a big map update syntax here, and we're going to implement the pieces to update position, orientation, and moves as we go. So in this case, I'm going to start with a move, and I'm going to update moves. Let's go ahead and collapse this. I like that better. So I'm going to essentially build this list head first, as I showed in Elixir. So I attack a move onto the moves, and that's it. So actually, I like the idea of having a single level of abstraction. So here I'm going to so I'm going to have an add move, and I'm going to take a move, moves, and a move. And this is a tiny function, so I'll one-line it. And I'm going to say, just like that. And so I'm going to update moves. And in that, I'm going to put add move, rover dot move, and move. So that should treat me well, at least I hope so. Okay, so we're compiled, and let's see if our rover is working. So rover.new, right? And this is where that API, our thinking in the front and naming the concepts is paying off for us. And I want to move, and let's say we move forward. Okay, we expected a map and got a 102. So for rover.move. So let's see what's happening here. Okay, so we're on line 111. Oh, this is a rover. Okay, and let's recompile. Okay, and we can see that we're starting to accumulate moves just as we should, right? So this is kind of this is kind of going to be the flow of how we work. We're working on building one big fat reducer, right? With this as an accumulator, and this is the item. Notice that this is a little bit, this is opposite the way that Elixir would have me write a reduce. But so since I am in the rover module, I'm always going to lean to listing rover first. And if I have to do a reduce, I'll just reverse the order of the inbound arguments. So let's go ahead and change the orientation. And in changing an orientation, there's a better name for that. Let's call it turn. And that's going to take an orientation and also a move, right? But this time I'm going to take advantage of pattern matching. And I'm going to say if I'm going right, I want to process it one way. And if I'm going left, I want to process it another way, right? So in this case, what I want to do is, and I also need to handle the forward. So if it's anything else, so forward, I'm not going to change the orientation at all. So that's pretty easy. So so basically, this is going to look at the orientation, and based on that, I'm going to build cases for north, and then I want a south, and then I want an east or a west. Let's do east first. And then I want a west. The nice thing about these is that they're the mirror images of each other. So I can take this one and basically build the mirror image at the same time, and just take advantage of my editor here a little bit. So a right turn, oh, I should have spaces here, right? That'll make it easier for me. Okay, so a right turn from north, moving right. So this is going to take me to east, right? Or left from south is east, and the opposite is also true. So this is going to take me west. And same thing for east. East, I'm going to, if I'm going eastbound, I take a right, that's going to take me to south. And the opposite is true of the left turn. Okay, so now, now I have private functions to update the orientation, and so my token is coming along. And so whenever I get any kind of move, I'm going to say turn, and I'm going to pass that the rover orientation and the move. And so now we should be able to see this at work. Never works the first time. We'll go ahead and give it a try anyway, right? So let's do a right. Okay, so it looks like our orientation from north changed exactly like it should. And so let's do a couple more of these, right? That's taking me to south. And this is taking me to west. So it's going around the compass exactly like it should. And you can see that it's accumulating moves exactly like it should. So that's great. We now have two pieces of our token moving. So let's go ahead and extend this concept to updating the position. The position is a little bit more complex because I have to take into account the orientation and also the position when I move. Basically because advancing does takes advantage needs both of those things. So let's go ahead and write a function called advance. Okay, and so remember, we're looking at orientation, position, and move. Right, but in this case, we don't really need the position. We need to break down we need to deconstruct that to its X and Y. And we're actually going to, rather than pattern matching on this and a bunch of different pieces, we're going to do a case, and we're the case of the orientation. And I'm going to build these in pairs because it's easier for me to think of them in that way. I'm going to look at the north and south first. So if I'm heading north, then what I want, then I basically want 0 and y plus 1. And if I'm heading south, I want something similar, but with a minus 1. All right, and I'm going to copy this whole concept for east and west. So west is minus 1, but these are going to be x's. And and here's a bug here. I'm sure you guys saw it at home and were yelling at your microphones frantically. Like to keep you on your toes that way. Okay. Yeah, that's not beer, guys. Just in case you think I'm coding and drinking. Okay, so what's breaking here? We have undefined function turn. Okay. Oh, yep. We don't want to turn, we want to advance. Right? So let's try this again. Variable move is unused. Okay, so I bet. Oh, I see the problem. So here we want to pattern match on advancing. And then for any other, or actually that's forward, isn't it? Is that what we said we're going to do? So if it's forward, we need to do this. If it's anything else, so this is position. And I don't really care about the orientation. And this is a one-liner. We're going to return the position. The position stays unchanged, right? So let's see how that works. Okay. And let's move forward. So this should be facing east, then south, and move forward, which should give us 0, -1. And that's exactly what's happening. So, okay, so we're at the do fun piece. We're about to move on to things, which is tests. And so what I'd like to do for this piece is to kind of introduce you to a concept. We're not going to add a whole testing stack for this. So I don't have time to introduce the concept of property-based testing, but what I would like to do is introduce the concept of introducing our own assertions that are composition friendly. Because I think that when you think in terms of reducers, then your test can be really beautiful and powerful. So let's go ahead and do that. So I need to create a test. And this test is just going to be a Rover test. It's an EXS because that's a script. I'm going to grab the top matter here just because I cut and paste that way. And this is Rover. And I don't need a doc test. So let's say test moves around a bit, right? And so let's say we're going to set up expected and then do some stuff here, and then actual and do some stuff here. And then we're going to assert expected is the same as actual, right? And so this piece is actually pretty. And the reason it's pretty is that we built our API that way. So for example, I can take something that looks a little bit like this. Let's say that that's the test we want to write. I'm short of time a little bit. So let's go ahead and paste that in right there. So, and let's go ahead and do things this way, right? And so we know where this rover is going, but let's say that there were another couple of directions in there somewhere, like this one, and then maybe take a left turn in there. So what's the actual? Okay, so I'm going to do a couple of things. First, to save time a little bit, I'm going to do something a little bit ugly here. Sometimes if I have a really simple API, I'll do an import. So in this case, I'm going to import Roam dot, and I'm just going to use these pieces directly, right? And so I'm going to go ahead and let this fail so that I can decide what a working test looks like. So for my live coding demos, and this is Roam. So Okay, so I failed basically because the rover is wrong, right? And so I could do this. That's kind of ugly. Yeah, that's really ugly. I don't like it. Because basically this doesn't, I'm going to have to take this apart mentally every time I jump into these tests. But the nice thing about it is it's going to pass. Okay, and I should be compliant here. So I'm okay with this, but I think my test can look a little bit better. So what I'd like to do is take a couple of checkpoints, like maybe one here, and say, what should my attributes be? And maybe throw in one here and throw in one here, right? So, well, maybe we have one at every step. Let's think about what this thing should look like, right? So, and actually, if I check my assertions in these places, then I actually don't need the expected, and I don't need the actual anymore, right? And that's what my test becomes. So let's think about what this should look like. Well, I think that this should look like an assertion, right? So let's say this is assert field value of whatever you're passing in, right? And so maybe after a right-hand move, I assert the field value. I assert that the orientation is in fact, so if I'm turning right, then this should be east, right? And so now it's pretty easy to think about this in terms of I'm turning right again. So this should be south. And then this one is changing. So right and a left. So in this case, I'm turning back to east, right? And so the nice piece about this API is it becomes very easy for me to reason about how my drone is moving around. So I'm going to assert the position. So the position has changed to we've moved forward one from east, and this is changed because we have moved forward one from south. And you can see how much easier this is to reason about and how much easier this test case will be to manage. And this is ridiculously simple to add. So let's say it's just a function, right? And this is going to take a drone or a rover. Sometimes I say drone. If I do that, it's because in my mentoring groups, sometimes we make a rover that moves around in 3 dimensions just to kind of get people thinking spatially a little bit. And it's a very similar problem, but drones are a little bit kind of more interesting for some. Okay, so then we're going to take a field and then take an expected value, right? And so the nice thing about this is that when I run my assertion, I don't actually have to return that value. The way that assertions work in Elixir is that I am actually going to be taking that assertion and running that through an Elixir OTP server. And so I am free. So that's already done all of its work and all of its reporting by the time that it gets to the return value. And I am free to return the thing that I need for composition here, which in this case is our rover, right? So I'm going to return the rover. And here I'm going to say the actual is just a map.get. Rover field, and then I'm going to assert actual. Let's call this actual value, just because it names the concept better. There we go. So let's go ahead and run this test and see if it works. Okay, so undefined function, assert field value of 4. So 1. Okay, so what line was that on? Assert field value of 4. So this is actually called on a Rover test on line 14. Oh, there we go. Okay, let's try that again. And this actually works. If I hadn't had just kind of the fat finger there, the little syntax error that really didn't have anything to do with mentally understanding the test. This thing, I didn't have a reasoning problem as I was writing the test. And I was actually writing the test as I was talking about it. Now, I was doing it with a list of directions that I'm not moving or that I've never used before. So there was a lot to think about. But since I was able to think in one small step at a time, it was easier for the test to, it was easier to visualize the test and easier to actually use it. Okay, so we're going to do one more thing. We're going to look at our boundary layer. And I know that that some of you have already seen OTP servers. But what I'd like to do instead of actually writing the OTP server used by just blindly plugging in values, I'd like to build the intuition for how the OTP server is going to work. So basically, the job of OTP is, in this case, is to maintain just a little bit of state, and that's the state of our rover. The problem is that we can't mutate any values. So if I have a server that's effectively calling itself in a loop, the only way that I can change a value is to take a value, is to receive a value from some type of function and then return that. Well, we're going to play some games with that function a little bit to make that work, and I'll show you what I mean. So we're going to create a new file, and that's going to be called the server. Sometimes I'll build a special external boundary name, but in this case, server works fine. So in this case, so I'm going to go ahead and grab some of the ceremony. And this is a boundary server. Okay, so there's a boundary server, and what I'd like to do is build with processes that something that looks a little bit like OTP that will process this. So the ninja move here is actually a function called listen. So listen is going to take a state. So, and it's going to return the result of a message that I pass to it, right? So there are two messages that I want to process, and one actually moves the drone around. So let's create that. So it's a tuple with move, and whatever move that you want to apply to this state. This is the rover. So, and the nice thing is that this implementation is very simple because we already have it. This is just, we're going to use the rom.core and rover. Okay. Yep, that's right. So we're actually going to use rom.move, and this is going to take the state, which is a rover, and the move. And that's it. And then there's also another, let's actually indent this, and that would be fine. And I actually have a different kind of message. If I send the state to this thing, it's going to look like this. So in this case, I have to take the state, and I need to know who to send this back to. So the process ID, but let's name this because I like to name concepts. Let's call this from. And then the first thing we're going to do is say send. So I'm going to send the process labeled from. I'm going to send it this message. So the thing that I want to return here is just a state, which is just Rover, right? But then I have to return the state, and that's it. So what I have here is something that this is a function that I can use inside of a loop that can manipulate the rover, and then now I can call this in a tight loop. Right? So what is run going to take? Well, it's going to take a state. And what's it going to return? Well, it's going to loop, right? And what's the state called? It's called a rover. And so what is that going to do? Well, it's actually just all it's going to do is listen. And that's it. Right? And so now starting this thing gets to be pretty simple. Let's go ahead and use this much of it. Okay, I can't believe that thing compiled the first time, but we'll go with our blind luck. And so now we have to start this thing. And so process dot, we want to spawn it. And all that I need to give this is going to return a PID. Actually, let's leave that off for now. So we're going to take a function, and that function, all it's going to do is call and this needs to call this function right here, right? And so this was run, and I take a internal, just the initial state of this thing, which is just rover.new. Okay. So process spawn2, let's do okay, process spawn, let's do process spawn2. Okay, so in this case, I'm taking a I don't want to monitor. So let's say, oh, this is just spawn, right? I don't need process spawn. I need spawn. There we go. And I've returned a PID. So I didn't pick up the PID when I ran from the shell, but that's okay. I could still have access to it. So I'm going to say server. So this is line 23. And I'll have to say, give me the value from line 23. Right? And now I can say, for example, so I know this thing has state. But what I can do is actually start to fire this thing commands, right? These commands right here. So for example, I could say send my server the command of move, and then forward, right? And I can also send the server a command of state, right? So now I have this PID. I've sent a message across to here. It was received here. The first thing that it did is send something back to my PID, which is this one right here, self, right? And what is self? In this case, self is 0.165.0. And so I sent the message back, and then I just returned the rover. And so the message that was sent was this one. So I ought to be able to say receive do, right? And then I could say message, and just with that message, just return it. And here's our rover that's moved forward one space, right? So I notice we're a little bit late here. Anthony, is it okay to go on for about 10 more minutes? What do you guys think? It looks like the attendees are still holding strong. I think I'm going to go ahead and move forward for probably 5 or 10 more minutes. I've covered just about what I need to. So, so this is how this layer works. What I'm not going to do, I need to build a start link, but we know what that start link looks like. It's the spawn that we just wrote. And I also would like to build an API layer, right? And the API layer can live here. So for example, state, and the state is going to take a PID, which let's call server, and and then I'm just going to do my gen server send right there. And then I'm also going to have a function called move that takes the server and the move. And then these things call gen server call and cast, or in this case, these are just straight process sends, right? Exactly like these that we did right here. And in the case of the state one, I also have to do the receive and return that value. But that's it. That's all gen servers. That's how a base gen server works. So this is the boundary layer, and the only thing that's different in the boundary that you'd see in an OTP application is that you would actually use the callbacks that are already. You would actually use the gen server that's already been written by Ericsson and the OTP team, right? And so the nice thing about this system is that we have a lot of pretty sophisticated machinery here, but it's machinery that's pretty common across all applications. And so that complexity falls away. And if we keep this isolated from the rest of our application, then we never have to conflate the concerns of the external machinery and the internal processes. And that makes it really easy to do things like property-based testing. We can do that on this layer, the Rover, very simply, right? These are very mathematical rules, and we can handle tests however we want to. There's going to be another testing layer that's on the server. It's on this server layer. But I think that's all I want to say here. I do want to talk about a little bit, just very briefly, about the last two layers. First, let's skip ahead to the wildebeest. Do fun things with big, loud wildebeest. That layer is the worker layer. And the worker layer is effectively just a layer that doesn't fit in the life cycles. It's not pre-configured policy, but it still manages processes. And the most of the time, when I need to spin up a worker in my application, I'm going to rely on somebody else's work. So I might use Poolboy. If I'm trying to do some database abstractions, I might use Ecto. All of these things. It's so whenever possible, if I'm injecting concurrency management into my application, I want to let somebody else deal with that work and the complexity. And the nice thing is that by providing these layers, it's easy to do so. Okay, so the last piece that I'd like to talk about is we're now at the life cycle. Do fun things with big loud. So the L for loud is the life cycle. And you've probably noticed that I'm not using a much beloved Erlang and Elixir name, which is the supervisor. And the reason is that I think that that's a clue for us to think in perhaps a more complex way than we need to. The way to think about this, if you've ever seen a British comedy called The IT Crowd, there's a couple of people that work in the basement, and 90% of the show is those people trying to find a different way to answer a customer support question, and that's or to answer the customer support question. And the answer is always, did you try turning it off and on again? And that is the genius of Joe Armstrong, of Robert Verdang and the rest of the Ericsson crowd. So if you can define how to shut an application down cleanly and how to start it up cleanly, many of the problems go away. So for example, layering startup is easy because you not only have a single supervisor, which knows how to manage the lifecycle, you can have a tree of them. And error recovery and the self-healing part gets very easy, right? Because now whenever there's a failure, I can restart, or I can code the policy that either restarts me in the last known good state, or maybe I can completely ignore the error, or maybe I can split the difference and maybe fail 3 times. But all of this can be done with configuration and policy. So the last thing that I want to show is that this solution is really also part of the brilliance of Erlang and Elixir, right? So when I talked to Jose, I told him that I didn't know how he considered all the different types of use cases that he was going to get thrown at the Elixir product. And he told me it's turtles. Maybe we should have named the book out of turtles instead of wildebeest. He said, Bruce, it's turtles all the way down. That means that every application, every dependency, it's either a library that doesn't need this infrastructure, or it's a turtle. It's an OTP application that knows how to manage its own application or its own lifecycle. And we can see this in the console. So there's an application object. And so I hit tab to find the completion pieces, but you can see a couple of pieces, loaded applications and started applications. And let's run them. So the loaded applications, well, this gives me all the IEX pieces, all the mix pieces, all the turtles all the way down. So if I do something like raise and boom, I get a runtime error. If I start another process, that crashes the kernel, and the error is not wrapped, you'll see IEX start again in the last known good state, which was with the command line or the instruction pointer of 1. Okay, so I think that's about all the time that we have to talk for. I hope you've enjoyed this podcast. I think that we have a little bit of time for some questions now.
Yeah, thank you so much, Bruce. Everyone was loving that chat. And when you asked for 10 minutes extra, we had some people saying give him 30. So really engaged. So thank you so much. We do have a few questions coming in. We've got one from an Erlang developer who likes the capability of capturing crashes in the crash.log file and wanted to know if there's an equivalent system that can capture logging of errors in Elixir.
I don't know. Just don't know that one. I could find out for you, but I bet you can post that to the Elixir forum and get an answer pretty quickly.
Cool. We have another question that says, in a general sense, how do you go from a mental model of your problem to your module construct?
Yes, so that's a great question. So the question is, how do I go from the mental model to the actual modules? And so the process that we teach has two pieces in the book. The first one is that we start with the right data, and we try to start with something that is pure. And when I say pure, don't be a slave to pure. In the book, you will see our core functions have random built in. And if you're thinking about pure in the Haskell sense, that's not a pure layer, right? If you're thinking about a timestamp, that's not a pure layer. But I am vigorously waving my arms with air quotes when I say pure. But basically, if I start with the pure functional with the pure functional core and start with the modules inside that, and I don't corrupt that thinking with other concerns like persistence yet, right? That gives me a much better chance of getting the model right. And when it's time to add persistence, I can either build an ecto layer outside, or I can build a separate context. I have a lot of options, but the way that I think about my construction is I think about things in expanding layers. The quote pure layer inside that functional core allows me to, particularly if I scrub data as it comes into the core with some type of validation, then that allows me to basically be more free and compose with things like pipes inside the core, just like you saw me do here. So you might, if you're a hardcore systems developer, you might think in terms of composing with width and think that pipes are dead. Well, that's not the way I think. The way that I think is that when you're in the core, you try to compose with pipes and you try to make things composable with pipes. And when you're in the boundary, then you compose with width. So, so my thought process is, how do I build one slice of the problem? How do I build the core first? Then what are the processes? And that's going to tell me where the gen servers are. Then how do I take about those processes? Then I'm going to say, okay, is that enough? If it's not enough, then I probably need to think about workers in some terms. And I can do things with, for example, tasks to kind of spin up workers, or for example, task async stream to spin up workers. And then once I have one component of that, then I'm thinking, then that's a turtle, right? That whole thing is a turtle, and I can think about my application design of how this level of turtles works together, where the level is the OTP applications. So sorry to take for so long for that one, but that's just such a great question, and right in the middle of why we wrote this book.
No, perfect, and thanks for such a great answer. We have time for one last question, and that is, has anyone used OTP where it didn't really add value that you know?
Yes. So basically, one of the things, if you get this book, one of the disclaimers that you're going to hear over and over and over is, don't use OTP if it doesn't add value, right? So one of the things that that folks often do is new object-oriented developers say, hey, Bruce, the thing that you just built, that looks an awful lot like an object. So I'll build objects everywhere, right? And when you do that, you're adapting, or you're adding a lot of potential complexity where there just doesn't need to be any. So one of the things that we wanted to do in designing Elixir systems with OTP The reason that that's not an OTP-centric name, that OTP is actually the last word in the name, is that we want folks to think about OTP as a process and reliability construct, not a construct for building applications from scratch and thinking about data. It's about processes, not data.
Perfect. Thank you again so much, Bruce. That was such a great presentation. Thank you all for attending. We'll be sending a recording of this webinar to your email, so please do check. Bruce has kindly offered 20% off for his latest book, which will be including details of how you can claim that in the email with the recording of the webinar. There'll also be details on early bird offers to see Bruce talk at both Code Elixir in London and then at Gig City, which is the event that he runs later this year. If you do have any other questions or recommendations for speakers for future webinars, please don't hesitate to get in touch with me at Erlang Solutions on Twitter and on Facebook. We'd love to hear from you. Thanks again.